I am Sai Kirtan from CSE. Today, I am going to explain about the topic unit cell. Introduction to unit cell. A unit cell is the smallest repeating unit in a crystal lattice. It defines the symmetry and structure of the entire crystal. Understanding unit cell is crucial for studying crystallography and material science. Types of unit cells. There are several types of unit cells, including simple cubic, body centered cubic, and face centered cubic. Each type has a unique arrangement of atoms that influences the material's properties. The choice of unit cell can affect the density, stability, and behavior of the material. Unit cells are the building blocks of a crystal structure. They represent the smallest repeating unit that, when stacked in three-dimensional space, forms the entire crystal lattice. There are several types of unit cells, categorized based on their geometry and lattice arrangement. First, primitive or simple unit cell. Atoms are located only at the corners of the unit cell. Key feature: each corner atom is shared by 8 adjacent unit cells. Example: polonium PO. Centered unit cells. Second, centered unit cells. These unit cells have additional atoms positioned at specific points within the cell, apart from the corners. In that, we have different types. First one is body centered cubic. In body centered cubic, rather than the atoms at the corner, we have one additional atom located at the center of the unit cell. Next, second, face centered cubic. Face centered cubic atoms are located at the corners and the centers of all six faces of the unit cells. The next, base centered. Atoms are located at the corners and at the center of the two opposite faces. This is known as the base centered cubic. Now let's see about lattice parameters. Lattice parameters are the measurements that define dimensions of a unit cell. These include the lengths of the edges and the angles between them. Accurate determination of lattice parameters is essential for characterizing materials. Lattice parameters define the dimensions and geometry of a unit cell in a crystal lattice. They, they describe the physical arrangement of atoms and are essential for characterizing the structure of a crystal. Here are the key lattice parameters. First, lattice constants. Lattice constants are the edge lengths and angles of the unit cell. They are typically denoted as A, B, C, and alpha, beta, gamma. A, B, C are the lengths of the edges of the unit cell, and alpha, beta, gamma are the angles between the edges. Lattice constants In lattice constants, ABC lengths are measured in angstroms or nanometers, and angles alpha, beta, gamma are measured in degrees. There are different factors which affect these lattice parameters. Lattice parameters depend on atomic size, crystal structure, temperature, pressure. Atomic size. Larger atoms increase the lattice constant. Crystal structure. Packing efficiency in structures like FCC, BCC affects the parameters. Temperature. Thermal expansion can change the dimensions. Pressure. High pressure can compress the lattice, altering the constants. Unit cell volume. Unit cell volume. The volume of the unit cell is calculated using its lattice parameters. It plays a significant role in determining the density of the crystal. A higher volume typically corresponds to lower density, affecting material properties. The volume of a unit cell is a measure of the space occupied by the unit cell in the crystal lattice. It is determined by the lattice parameters and depends on the crystal system. Here's how it is calculated. Uh, the general formula for calculating unit cell volume is V is equals to A in, V equals to A into B into C into under root of 1 plus 2 cos alpha 2 cos beta cos gamma minus cos square alpha minus cos square beta minus cos square gamma, where A, B, C are the edge lengths of the unit cell and alpha, beta, gamma are the angles between the lengths. Now let's see some of the volumes for different crystal systems. First, cubic system, where all sides and all angles are equal. In this case, volume of the cubic system unit cell is AQ. For a tetragonal system, two sides are equal but third side is not equal to the two sides and all angles are 90 degrees. In this case, the unit cell volume of tetragonal system is A square into C, where C is the length which is not equal to the other two lengths. Unit cell is expressed in terms of cubic angstroms or cubic nanometers. Now let's see about Bravais lattices. Bravais lattices categorize the different possible arrangements of unit cells in three-dimensional space. There are 14 distinct Bravais lattices in crystallography. Each lattice type has specific geometric configurations that influence crystal behavior. Uh, Bravais lattices. The Bravais lattices